Last week we learned about cyclic quadrilateral, you still remember? Okay, today we are going to continue with 6.3, that's tangents to circles. Okay, now we look at what is tangent to a circle. Okay, if you look at the diagram here, we have a circle with a straight line. Tangent to a circle is a straight line that touches the circle at only one point here. Okay, so this line is called a tangent to a circle. And then this point here, it is the point of tangency. Okay, if you look at the diagram on the right here, let us find out which one is the tangent to the circle. Okay, how many tangents to a circle are there? There are two, right? The first one is line PQ, and the second one is line RS. Okay, Y is the point of tangency for line RS, and X is the point of tangency for line PQ. Is UV a tangent? No. Why? Because it touches the circle at 2 points. So if it touches the circle more than 1 point, that will not be a tangent to a circle. Okay, now we look at another diagram here. Can you tell me how many tangents to a circle are here? How many? There are 2. Okay, the first tangent to a circle is line PQ, and E is a point of tangency. The second one is line TU because it touches the circle at only 1 point, just like line PQ. Okay, and then for line RS, it is not a tangent to circle because it crosses the circle and it touches the circle at 2 points. And then line MN, also not a tangent to circle because when you extend this line here, it will touch the circle at 2 points. Okay, now we look at the next slide. From brainstorming 7, it is found that the radius of a circle, this one is the radius, that intersect with the tangent to the circle at the point of tangency here, will form a 90-degree angle with the tangent. So it will form a 90-degree. Okay, you just remember, no matter where is the radius, as long as it intersects with the tangent, then it will form a 90-degree angle with the tangent. Now we look at the next slide here, example 15. The diagram on the right shows a circle with center O, which meets the straight line ABC at point B only. So this is the center O, and then it meets with the straight line ABC. This one is the diameter. Okay, if this is the diameter, meaning that OB is the radius, right? Here the question asks you calculate the value of X. This is the value of X over here. Okay, just now we already found out the radius that intersect with a tangent of the circle will form a 90-degree angle here, right? So in order for you to find X, you just need to look for angle AOB here, this part. So if you are given 138 already, this is a straight line, meaning that it will be 180 minus 138. So the angle of AOB will be 42. 180 minus 48, it is 42. Therefore, to get the value of X, it is 90 degree here minus 42. The answer is 48. Okay, now we look at the next one. If you have two tangents here, this is given two tangents AB and also AC. Okay, if two tangents to a circle with center O and points of tangency B and C meet at point A, okay, meaning that the tangents, when you extend the line, it will meet at A. Then BA is equal to CA, meaning that the tangent here, the length are the same. Okay, and then angle BOA, this is angle BOA here, the angle X is equal to angle COA, the angle X here. And then angle OAB, this is OAB, which is angle Y, is equal to angle OAC, angle Y. Okay, can you remember? If you have two tangents, 1, 2, and then there will be two radius like this, the tangents will be the same, the angle here at the center will be the same, and also the angle outside here will be the same. Okay, now we look at example 16. The diagram on the right shows a circle centered at O. So this is the center. Tangents PQ and RQ meet at point Q. So this is PQ, RQ meet at point Q. Calculate the value of X. You have to find the value of x over here. Okay, so to find out the value of x, we learned earlier that whenever a radius intersects with a tangent, it will form up 90 degrees, right? So if you want to get the value of x, just use 90 to minus 66. Therefore, the value that you have for x is 24 degrees. Okay, now to find the part B here, the value of y will be equal to the length of PQ, which is 14 centimeter. Okay, so you can see the answer here, 14 centimeter. Then they ask you to find the radius of the circle. To find the radius, you're given the angle of x, you're given the length over here, and this is the radius that you have to find, which is line PO. So from this angle here, the line that opposite this angle is the opposite side. Okay, remember you learned this in the trigonometric ratio. And then this length here, the side PQ, will be the adjacent side. So the corresponding ratio is O and A. Therefore, you are going to use 10. Okay, so you can see the solution down here. Tan 24 degrees refer to this angle is equal to OP, the opposite side, over 14 centimeter. So OP over 14. Okay, so to solve it, OP is equal to 14 times tan 24. You just need to press your calculator. Then you'll get the radius of OP, which is 6.233 centimeter. Okay, if they didn't ask you to run it off or anything, then you just keep it in 6.233. Now we look at the next slide here. We are going to look at the relationship between the angle between the tangent and the chord. Okay, this one is very important because you need to identify what does it mean by all of this. I have to underline this, angle between tangent and chord, or it can be said as angle between chord and the tangent. Okay, with the angle in the alternate segment, which is subtended by the chord. Okay, we look at the first diagram here, this one. So, angle between a chord and a tangent. I change it to pointer so it's easier for you to see. Okay, this is the chord. This is a tangent. Angle between a chord and a tangent here is labeled as x. Okay, and the other one is angle in the alternate segment, which is subtended by the chord. Where is the chord? This one is the chord, right? This is the major segment. So angle subtended by the alternate segment of the chord here is angle y. Okay, the value of angle between a chord and a tangent, they are the same with the angle subtended in the alternate segment, which is subtended by the chord. So x is equal to y. Okay, now we look at this diagram. So you can see this is a chord, this is a tangent, meaning that this is the angle subtended by a chord and a tangent, right? Okay, and then this x, which one is equal to the value of x? Which angle is equal to x? You can see angle y, right? Because angle y here is the angle in the alternate segment subtended by this chord. Okay, so angle y here. If you look at theta, theta is angle subtended by chord TQ and also tangent PR, right? So which one is equal to theta? Theta is equal to the angle subtended by this chord at the alternate segment, which is beta. Okay, therefore angle x is equal to angle y and angle theta is equal to angle beta. Okay, next we look at example 17 here. In the diagram on the right shows triangle KLM and PMN is a tangent. So this is KLM, a triangle, and this is tangent. They ask you to determine the angles in the alternate segment for angle PMK. Okay, so which one is angle PMK? Angle PMK is over here. So this is the angle subtended by the chord KM and also the tangent, right? It will be equal to the angle subtended at the alternate segment by chord KM. So from chord KM, angle subtended at the alternate segment is angle KLM. Therefore, you have the solution angle KLM. And then find out the angle in the alternate segment for angle NML. Now we look at NML. This is the angle NML. This is the chord. Okay, the chord subtended at the alternate segment here is this one. So the name of the angle is angle LKM. Okay, this is the solution. Now we look at example 18. The diagram on the right shows the triangle ABL inside a circle. Given that KLM is a tangent to the circle, determine the value of x. So your x is here. This is the angle subtended by chord AL at the alternate segment. So it is equal to the angle subtended by the chord and tangent KLM. Therefore, the value of x is equal to 60. They are the same. X is equal to 60. Okay, and to find out the value of y, this one, this is the angle subtended by chord BL and also tangent KLM, right? So it is equal to the angle subtended by this chord at the alternate segment, which is 54 degree. Okay, y is equal to 54 degree. Okay, so that's all for our lesson today. I'll see you again next week. Bye.